Chalo, comes on everyone. Let's start off. This was the homework that I gave you. Anyone got an answer for this? How do we do this? See. So from here, draw the normal. So this angle would be half of the angle 5/2 because I is equal to R. From here, if you draw a tangent, that would be your tangent. So with the horizontal, if that is 5/2, this is 90 minus 5/2. This also will be 90 minus 5/2. Agreed? Is that clear, everyone? Or we can do the other way also. When you made them join here, if that is 5/2, this is 5/2, agreed? And this angle is 90 degrees. So this is 90 minus 5/2. Then this angle will be 90 plus 5/2. Are the angles clear, everyone? So what is the slope? Slope of the tangent is tan of the angle 90 plus 5/2, which is nothing but minus cot 5/2. Tan 90 plus theta is minus cot theta. Clear? And then, but what is the slope of the tangent also? Slope is nothing but dy by dx. Maybe now I should have given you some angles to make it easy actually. But okay. Maybe I could have given some 60 degrees or something. That could have made it easy. Now you have to find phi, right? Sorry. So what is dy by dx? That's the differential of sine x. So differential of sine x is cos x. So we have cos x is minus cot 5/2. So x ka value is 2 pi by 3. So that is cos 2 pi by 3, which is cos 120 is minus cot 5/2. So that is cos 120 is minus half is minus cot 5/2. So we have cot 5/2 is half, or you can also write tan 5/2 is 2. Therefore, phi is equal to 2 times tan inverse 2. Yeah, that's how you represent the answer. Check it out. Clear with the steps? So again, what did I do? I draw the normal here. So that will make 5/2. So this is 5/2. This is the tangent here. So that will be 90 minus 5/2. So the slope of the tangent is tan 90 plus 5/2, which is cot minus cot 5/2. And then you can simplify. Slope is also dy by dx. Everyone clear with this? Clear? Shashwat? Tanish? Mridul? Arush? Archana? Clear? Vihan? Got this? Perfect. So that was the one of the homework problem I gave last class. Now let's go ahead. Like I said last time, in differentiation, there are 3 levels. The first one was what I showed you last time. The second thing is identities. The first one, if you have dy by dx of a constant into function, the constant comes out of the integral. Example, if someone asks you to differentiate d by dx of 3x square, so the 3 is a constant, right? So push it 3 outside. Then this will become dx square by dx. This thing looks like x power n ka integration, where n is equal to 2. So this is 3 into 2 into x power 2 minus 1, which is 6x. Getting this? So these are the 6 identities I gave you last time. Remember x power n ka differentiation. X power n ka differentiation is n into x power n minus 1. So if you have a constant into this, you can do this. Second, d by dx of f of x plus or minus g of x. So if you have two functions, addition or subtraction, and you have to differentiate, then it is d by dx of f of x, differentiate f of x separately, and differentiate g of x separately and add them. Example, if you ask me to differentiate d by dx of x square plus x, so I can separate this thing, dx square by dx separately, plus dx by dx separately. So for this guy, n is 2. For this guy, n is 1. So the formula will be 2 into x power n minus 1. This is 1 into x power 1 minus 1. That is 2x plus 1. Is that making sense, everyone? You can note down this stuff. You can put on these main formulas here. We're going to use it now. You can put on the things in the circle. Clear, everyone? The next one. Turn in the page. Brijesh, Archana, going ahead. The third identity, if you have d by dx of f of x into g of x, it's called product rule because you have two functions multiplied. So in this, what you do, so when you differentiate f of x, the g of x will be outside. And when you differentiate g of x, f of x will be outside. Example, if someone tells you to differentiate d by dx of x square into sine x, so basically you need two functions. So let's call this is f of x, and let's call sine x as g of x. So f of x, g of x are simply two functions. So how do we differentiate this? When you differentiate f of x, the sine x will be outside. And when you differentiate sine x, x square will be outside. So sine x is sine x, x square ka differential is 2x. Sine ka differential is cos x. 2x sine x plus x square cos x. Check. Getting how we are doing this function? Note it down. So we have four identities. So this is the product rule. Turning the page. Achita, go ahead. Clear? Next thing, the fourth identity. So d by dx of f of x by g of x, division rule. This thing, g of x will be outside. Then you differentiate f of x minus f of x will be outside. Differentiate g of x by g of x ka whole square. This is the most complex one out of all four. Example, if you have d by dx of cos x by x, this is f of x, this is g of x. Basically, you need two functions. If you substitute this in the formula, so g of x is x, differential of cos x minus cos ka differential is minus sin x, dx by dx is 1. Check. So this is the second level. So the first level is these four things. Straightforward. Differential of a is constant is 0. X power n ka differential is x power n into x power n minus 1. E power x is e power x, ln x is 1 by x, sin x is cos x is minus sin x. Hope everyone has mugged up these 6 values here. Right? Everyone knows this thing. So on top of it, we have 4 identities. Have a look at this. This is your second level. Let's do some practice problems on this. Today it will be more of max oriented. We'll have less applications. Can I go ahead? Mridul, Devika, clear? Clear, na, Devika? Going ahead. Now let's see some problems. So I'll give you some functions. You need to differentiate and give me the answers. dy dx of 4x cubed. Root x plus 1 by root x. Let's get this. Yeah. Easy stuff. Let's go. Let's go. Keep solving. Get all of them. I'll show you the answers. Every 30 seconds, I'll start showing 1, 1, 1. So just solve. It's okay if you don't type it. You can verify your answer. These are easy stuff. Meaning if you've already done in your classes. But if you've not done, you can do now. Anyway, I'm doing everything from the basics, ground zero. So shouldn't be a problem. That's what I keep saying. Most important thing, whatever you did in the last class, always you need to revise and come. If you just coming, attending the classes without doing the work, you'll find it difficult. The first one is easy. So this thing is 4 will come out is the first identity, x cube. Then x cube ka differential is 3 into x square. That is the second rule, if you remember, x power n ka differentiation. So we are using the first 6 formulas and the 4 identities. We are combining them. 12x square. So this can be written as dy dx of x power half plus 1 by root x is dy dx of x power minus half. So x power half is n into x power n minus 1. So that is minus half. This will be minus half into x power n minus 1. So minus 3 by 2. 1 by 2 root x by 1 by 2 x power 3 by 2. This is dy dx of x square. Dy dx of x power minus 2 plus dy dx of 2. X square is 2x. This is minus 2x power minus 3 plus 0. Constant ka differential is this, minus 2 by x cube. Please stop me. Anyone who's not getting these three, ask me the answer. Check me the ask. Those are the answers for ABC. Do verify your answers. You're stuck with something. You're not convinced with something. Please ask. Please, you can unmute. You can just unmute and ask. You're feeling shy. You can type your answers in the chat box. Tanish.
So can you explain C once more?
Which one? What did you do? You tell me. You tell me what you did.
So sir, I did 2x plus 1 upon 2x and then like.
Why 1 upon 2x?
So
See na, look at here. This is okay?
Yeah.
What is n there?
Minus 2.
So put it in the formula. What do you get?
So minus 2. Oh yeah, I got it. Okay. Like that. Minus
Got it?
got it.
Minus 2 x power minus 2 minus 1.
Yeah, I got
So
it.
minus 3 tha wo.
Got it.
We are using this formula, everyone. Dy dx of x power n is n into x power n minus 1. In this case, that's like I said, very important identity. What about d? E is what? E is f of x into g of x. The product rule. Try. I'll give you a minute for d. D and D, right? There's a much faster way to do this, something called chain rule. I'll teach you that later on. But first, let's do with the identities. Sin x into cos x. So this is the third rule. F of x into g of x. Hope everyone has written down these formulas. The product rule you have to use. Let's see the third one, D part. Dy dx of sin x cos x. So let this be f of x. Let this be g of x. So then apply the formula cos x d by dx of sin x. And then you have sin x d by dx of cos x. So when you differentiate one, don't differentiate the other guy. Cos sin x ka differential is cos x. Cos x ka differential is minus sin x. This comes out to be cos square x minus sin square x. This is nothing but cos 2x. Remember that formula? That comes from basic max trigonometry Remember this formula? Cos square theta minus sin square theta is cos 2 theta. Exam options will be like this only. No one will give you cos square x minus sin square x. Options will be cos 2 theta, sin 2 theta, and all. And you'll think like, how the hell did we get this? How did we get this? Max people teach you in trigonometry. So you should mug up that result. That's the answer for the D part. What about D, sin square x? Try. I'll give you another minute. So how will you do write sin square x? You can write sin square x sin x into sin x, isn't it? Again, you can use the product rule, f of x into g of x. Give it a try. So once you got that, try d by dx of tan x. Narush, let's see. We'll check your answer. Let's go. Go for E. Sin x into sin x is sin square x. You can split sin square into two parts. Let's see. Sin x into sin x. You can treat one of them as f of x. The other one as g of x. So sin x, differential of sin x. Again, sin x, differential of sin x. So sin ka differential is cos x, sin x cos x. So we have 2 sin x cos x. 2 sin x cos x is sin 2x. That's your second trigonometry formula if you remember. What about tan x? Devansh. That looks right. How to write tan x? D by dx of sin x by cos x, the division rule, the third one. Let's try everyone. In case you have done that, dy dx of secant x. Let's go. Whatever I'm giving you are like kind of little standard ones, which we will see them once in a while in physics. You're not going to do all weird things. That max people will do anyway next year. We will just do the max sufficient for physics. Try others. Try for tan x. I'll give you a minute and then I'll show you. I think, yeah, some of you did get the answer. But let others also give it a try. Let's see the if part. F of x. This is g of x. So substitute in the formula. So first to differentiate f of x here. Minus, then then denominator का square. Sine का differential is cos. Cos का differential is minus sine. That is cos square x plus sine square x. That is 1 by cos square x. That is secant square x. You can actually mug up this result. Differential of tan x is secant square x. So how do you differentiate secant x? Secant x is nothing but d by dx of 1 by cos x. So here 1 is f of x. So a constant is f of x. You can have any function. This is g of x. Again, division rule. Try. I'll give you 30 seconds. So everything you can put down in the 4 identities. Try. Just give it a try. Just get some water and come. Let's see your answer. Secant x tan x. Yeah, that looks right. Let's see. So again, use the formula g of x, that is cos of x. Differential of f of x, that is 1 minus 1 differential of cos x. So basically, wherever there is f of x now, put 1. So differential of 1 is 0. Cos ka differential is minus sin x. So that becomes sin by cos is tan x. Cos x is secant. Clear with this? I hope everyone is comfortable with the 4 identities now. Sarashwat, clear with this? You have an idea about differentiation, right? Yeah. Others, Devansh, Archana, clear, na? Archita, clear with this? This is your second level. Now there's a third level, the chain rule. I'll be sending you a sheet on all these things you can try to solve. So we'll just finish up the basic calculations part today. Applications mostly we'll be doing next week. We are on a break. I hope you remember. So next week we won't be having classes. So I don't want to start something in the middle. So once you're back, then we can start off with applications, which are quite important. Chain rule. Now what the chain rule says, if you have a function d by d of x, f of g of x. Mathematically, it will look weird, but let me give you some examples that will make it clear. So when you differentiate a function inside a function, we call it chain rule. First, differentiate the whole function, and then differentiate whatever is inside. Right? Let me tell you what it means. Listen to this carefully. Everyone focus, listen to the next few examples. You got the hang of this, you got this thing. It's more easy to get it from practice than actually understanding what it means. So let's say if you have a function sine of x square, you're getting it. Now, if you look at this, does this look like any standard function that you know? It doesn't look like the first 6 formulas, level 1. It doesn't look like the second level, isn't it? But it kind of looks like, this looks like sine of something, isn't it? Sine is one function, x cube is x square is another function. You getting this? So this is a function. So this is what we do. What is the first thing that you see? Sine. Forget about what is inside, okay? Forget what is inside. What is the first thing that you see? Sine. What is sine ka differential? Cos. So cos of that function, which is x square, then differentiate whatever is the function inside. समझ में आ रहा है? So first thing you take sine का differential is cos of x square. Then this thing is in the place of x, so we have to differentiate this guy. I'll give you more examples. So listen to all of them, and then if you're still confused, I'll explain you. So this would be cos x square dy dx is 2x. So the answer is 2x cos x square. One more example, see. If I say dy dx of cos, let's say 5x. Now, normally what is the function? Cos x, but x ka place mein you have 5x. So first thing, what is the first term that you see? Cos. What is cos ka differential? Minus sine 5x. So you just take the whole thing. But inside it is not x, so differentiate whatever is inside. So this is minus sine 5x, and 5x ka differential is 5 dx by dx. Dx by dx is 1. So minus 5 sine 5x. One more example. Suppose if you have dy dx of sine cube x. Now look at how is this looking like. This is looking like a function to the power of 3, isn't it? So your job is always to see how does this look like. How does this look like? It looks like a function to the power of 3, na? So this is looking like which identity? The second one, x power n ka formula. So something to the power of 3. So 3 into that some function n minus 1. But inside it is not x. So differentiate whatever is inside. So this will be 3 sine square x, and differential of sine x is cos x. Let me take one more example. Let's say dy dx of root over x square plus 1. So this is looking like dy dx of x square plus 1 whole to the power of half. So your first thing is forget about what it is. How does this look like? This is looking like some function to the power of half. Means it is looking like x power n. So x power n ka formula is half into that some function ka n minus 1, and then whatever is that function inside, differentiate it. So this would be half into x square plus 1 minus half, and this differential would be differential of x square plus differential of 1. So this would be 1 by 2 root x square plus 1. That differential is 2x plus 0. That is x by root over x square plus 1. Look at the third one. Third is what? Sine cube x is what? Sine x to the power of 3, isn't it? So this is looking like some function, whatever is the function, to the power of 3. So which identity is this? Which formula is this? Isn't this looking like this formula, x power n? Making sense? It is looking like x power n, but inside it is not x, it is sine. You getting this? So it is some function to the power of 3. So 3 into the function n minus 1. That is the formula, na? And then whatever is the function you have taken, usko differentiate karo. Please have a look at this. I know you understood most of it, but there might be little confusion. We'll do some 10-15 problems, so you'll get the hang of it. This is the most important one. If you got this level 3, I think your differentiation, how to differentiate, you know. Have a look at these examples. Let me give you more. The best way to learn is I'll give you problems. If you mess it up, then I'll teach you what went wrong and you will learn faster. But first, have a look at the 4 examples. So the idea is it will look like some function. So you always have to take the function, see which is forming, and then differentiate whatever is inside again. Have a look at this. Clear? Now, you guys try these things. We'll go one at a time, so don't worry. So dy dx of cos 2x. dy dx of e power 3x. dy dx of sine square 3x. Chalo, let's get these three. Let's make it e power minus 3x. Again, don't think so much. Whatever you understood, you try to do. I'll show you the answer, then see if it is right, great. If it is wrong, let's see what went wrong. Okay, let's see the first one. See, how does this look like? Cos of something. You're getting it? I see. Forget about what is inside. It is cos of something. So first thing, what are you seeing? Cos na? What is cos ka differential? Cos ka differential is minus sine of that something. Now differentiate whatever is that some function inside. Are you getting what we did? It is cos of something. I don't care what is that something. Forget about it. So cos ka differential kya tha? Minus sine something. And then differentiate whatever is that something. So the some function is 2x here. So 2x ka differential is minus 2. Minus 2 sine 2x. Check your answer. You didn't get this? Ask me. You're confused? Ask me. So that's what I'm saying. Don't think so much. You do whatever you think is right. Once I show you the answer, you can verify your answer. You understood, great. You're still confused, ask me. Look at the second one. This is looking like what? This is looking like this identity, e power x. So differential of e power x is e power x only. Now this is looking like e power some function. So that some function is 3x here. So what is e power something? E power something is e power something. And then differentiate whatever is that some function. Minus 3x minus 3 will come out and dx by dx is 1. E power minus 3x. Please check. Look at the third one. So first of all, let's write it in a way you can understand better. So d by dx of sine 3x. Now look at this thing. This is a function inside a function, inside a function, triple function. This is square. So this is looking like what? This is something to the power of n. So this looks like x power n. So what is the formula for this? N, that is 2, into that some function, which is sine 3x, to the power of 2 minus 1. Then what to do? Whatever is inside, uska differentiate karo. That is sine 3x. But now, what is this again? This is sine of something, isn't it? Again, chain rule aaya. Chain rule can set chain rule. So this is looking like sine of something. So this is 2 sine 3x differential of sine 3x. So this is again a new function, sine of something. So that's what I'm saying. Don't worry about what is inside. What is sine ka differential? Sine ka differential is cos. Now differentiate whatever is inside. That inside is 3x. So you can even differentiate triple functions, function inside a function. So this is 2 sine x cos 3x, and differential of that will be 3. So that is 3 into 2 sine 3x cos 3x. Remember that formula? In case you forgot to remember this, 2 sine theta cos theta is sine 2 theta. You should definitely mug up this. Comes a lot in physics. So this guy becomes 3 sine 6x. That is how the final answer will look in the exam. Meaning this is not wrong, okay? 6 sine 3x cos x. But problem kya hai na? Options will look like that. Please have a look at ABC. Anyone not convinced with this, please ask. Clear? Can I go ahead? Any doubts? Anyone not convinced with this? Soham, Tanish, Devansh, Devika, Archita, clear with this? Brijesh, Arush, Archana, clear? Next one, say d by dx of root cos x. D by dx of root over x square plus x. D by dx of cos square 2x. Let's get these three. Let's the first one. D by dx of this is cos x to the power of half. So this is looking like something to the power of half. So n is half. So this is half into that function half minus 1. Then whatever is inside, differentiate that. What is inside? Cos x is inside. So this is 1 by, that is root cos x, because cos x per half. Cos x is nothing but minus sin x. You can leave the answer like this. Minus sin x by 2 root cos x. Check. Check your answer for D, everyone. So it is looking like something to the power of half. That something is cos x here. So after doing x power n, you have to differentiate that cos x again. Anyone not convinced with the D part? Anything that doesn't look right, please ask. Be very comfortable. Matlab, you should get used to these things. Anything you have a doubt, don't hesitate, ask. Because these things are like bread and butter. Like you will get questions like more dangerous than this. मैंने आज ही कर रहा था. Tomorrow, today we did one problem like this. I was saying the same thing to your seniors also. There was a function like this. That- See, there is a function like this, and we have to differentiate this and get to something. It's a quite a common. We are going to do this now. It's quite a common thing. And really don't worry too much about this because once they teach you in max, na, these things are a joke actually. Right now, it might feel a little tough. These things are like small puppies. Max means they'll teach you Godzilla's. So these things are nothing. When they actually teach you in max, now you'll feel so happy about like, oh, itna easy tha physics. What about E? It looks like something to the power of half. Try. I'll give another 30 seconds, then I'll show you. Look at the next one. So this is d by dx of x square plus x whole power half. So this is something. So this is half into that some function x square plus x whole power half minus 1 and then differentiate whatever is inside. That is 1 by 2 root x square plus x and that would be 2x plus 1. Check your answers. This is d by dx of cos 2x ka whole square. So this is that sum function. This is 2 into cos 2x, 2 minus 1. Differentiate cos 2x. Again, when you differentiate cos 2x, this is again a function inside. 2 cos 2x, differential of cos 2x is minus sine 2x. Then differentiate again that 2x. Basically, you keep differentiating till you get dx by dx. This is minus 2 sine 2x cos 2x into 2. So this is minus 2. 2 sine 2x cos 2x becomes sine 4x. Right, Shashwat, you got that. Try. Others, have a look at this. Please ask me what you're not convinced with. Which one, Saraswat? The last, which two steps? You can unmute and ask me. This is clear. So this is fine. What is cos 2x ka differential? Minus sin 2x. But then you have to differentiate whatever is inside again. So that will be 2x ka differential. But 2x ka differential is 2. And this thing comes out. So this will become 2 cos 2x sin 2x. So this whole function is this guy. Right? And then I told you here, 2 sin theta cos theta sin 2 theta. Na? This you should know. Sin theta cos theta is 2 sin 2 theta. So I use this thing. So sin 2x cos 2x became 4x. Is that making sense? Still confused. Please ask me.
Uh,
Bolo
Sir,
na.
how did sin 2x cos 2x become sin 4x?
That's what I was saying. You should know this formula. 2 sin theta cos theta is sin 2 theta.
Actually, in our school, they only did wavy curve and then moved on to sets, so they didn't teach
Yeah.
trigonometry.
So remember now. For now, remember this till they teach you.
Okay.
That's okay. If that is a problem, that is fine. Once they teach you, you'll get the hang of it. But this is clear, no? All clear? Let's see few more. E power minus 2x square. Let's go. E power minus 2x square. What is e power x ka differential? E power x ka differential is e power x only. But here x ka place mein you have something weird. You have e power minus 2x square. This guy is there in this guy. Try. 1 minute for each. Let's say this one. So this is looking like e power some function. So this is e power that same function, because when you differentiate e power x, you get the same thing. So e power something is e power something, and then differentiate that some function, which is minus 2x square. So minus 2 comes out, e power minus 2x square. So now you're differentiating x square. X square ka differential is 2x. So minus 4x e power minus 2x square. Check. And for ln function, for people who don't know, dy dx is ln x is 1 by x. This is the standard result. Now, how we got all this, we're not interested. You need to mug up all this stuff, because maximum they'll teach you all this for 2.5, 3 months. Then they'll actually prove all this stuff. We don't need it. We are just interested in applications. So this is looking like what? Ln of something. So ln of something is 1 by something. then differentiate whatever is that some function. So just always think like that. This is looking like ln x, but x ka place mein you have 2x plus 1. So 1 by 2x plus 1. 2x ka differential dx by dx plus d1 by dx. 1 ka differential is 0. That is 2 by 2x plus 1. Get this I also. How I'm done. Finish off, finish off. Why are you playing with your fingers, cracking them ऐसे fight के लिए जा रहे हो अभी? Solve कर रहे रे calculus का problems. Fighting कहाँ पे जा रहे हैं हम? Solve. इतना में हाथ दुख रहा है क्या? बोर्ड एग्जाम में 3 घंटा कैसे लेगा आप सब लोग एक्चुअली? How did you guys like 3 hours का बोर्ड एग्जाम्स? Solve. This is nothing. ये सब क्या है ना? Actually, I'll tell you, the questions will actually look like this. There's a question like this, देखो. There are 6 charges. There is a charge floating on the center of an hexagon. उसमें कुछ force निकालना था. So we first find the force, and then we have to differentiate. So this differentiation will be a part of that question. No one will ask you differentiation like this. That's what I said. Once we do applications, it will be more fun. But then for that, your basics have to be clear. What is this thing? Answer for I. You're done. That is fine then. If you're done, you can crack your fingers. Tanish, done? You're cracking your fingers. So it is done. So you signal more. Once you're done, you'll crack your fingers like this. Yanta is doing yoga also. Okay. So let's see how to do this thing. D by dx of x square plus 3x to the power of half. So this is looking like some function to the power of half. So this is half. That function x square plus 3x to the power of half minus 1. Then differentiate whatever is inside, which is x square plus 3x. This is 1 by 2 root x square plus 3x. And that differential will be 2x plus 3. So 2x plus 3 by 2 root over x square plus 3x. Check. Please verify your answers. You messed up somewhere? Please ask me where you messed up.
Sir, won't it be
No,
minus
I
half?
did mess up. This is a minus half actually. This would be 3 by 2 with a minus. I messed up. Please check your verify your answer. X square. Yeah, that should be the answer. Clear? Let's see one more.
Sir, could you go back once?
All clear with this thing? GHI? Archita, clear? Got this? G again. G. देखो ना. G is like what? E power something. So e power something is what? E power something. Now what is something? Minus 2x square. उसको differentiate करो. So minus 2 will come out. What x square का differential is 2x. So that 2 and this 2 will become minus 4. And then x is left now. X square is 2x. So minus 4x. Sure?
Yes, sir.
Yeah. Still confused? Please don't hesitate to ask. Anyone? GHI? Anyone is not convinced with anything here? Can I turn the page? Turning the page. So d by dx of x by x square plus 2 whole power 3 by 2. Let's get this thing. These are the kind of functions you will see at least in 4 or 5 chapters. So you have a chain rule, you have a division rule, both combined. Or you can actually use product rule and chain rule, however you want. Try. Let's see. First, let's write this term properly. D by dx of x into x square plus 2 minus 3 by 2. You can write like this. So generally, you know what? I don't like the division rule. I like to do everything in terms of product rule. So you can do like this. Okay. So now this is your f of x. This is your g of x. So you can do with division rule also, nothing wrong. You would have got the same answer. So first let's try to calculate. So d f of x. So here you're saying f of x is x. Df of x is 1. G of x is x square plus 2 minus 3 by 2. So dg of x, which is x square plus 2 minus 3 by 2. So this looks like some function to the power of minus 3 by 2. So minus 3 by 2, x square plus 2 whole power minus 3 by 2 minus 1. And then differentiate whatever is inside. This would be minus 3 by 2, x square plus 2, 5 by 2. And that is 2x plus 0. That would be minus 3x by 2 into x square plus 2, 5 by 2. Please check. Now you can write this thing as x square plus 2 whole power minus 3 by 2, the product rule. So in a differentiate f of x, put g of x outside. Then differentiate g of x, put f of x outside. So dx by dx is 1. So this is x by square by 2 minus 3 by 2 plus this is x. Just now we differentiated this. So this whole function here is this, isn't it? This is the one in that green box. So I'm putting the same color here. Minus 3x by 2 into x square plus 2, 5 by 2. So if you can simplify this, this guy would be 1 plus x square by 2 whole power 3 by 2 minus 3x square by 2, x square plus 2, 5 by 2. Won't it be 6 in the numerator? This 2 and this 2 will cancel, na? Okay, there is a, yeah, 2 nahi aana chahiye. Yeah, I wrote an extra 2 here. That, hmm. You're getting? So basically, shit, this 2 will cancel. So I'm ignoring it. Please check. I hope I didn't do any calculation mistakes. But look at the steps. This is quite an important one. If you got this, I think your differentiation, you know how to handle now. This much is sufficient for physics. Anyone not convinced with anything particular here? All clear with this? Any doubts on this thing? Devika, clear with this? Ridul, Archita? Clear, na, Archita? Any doubts? Saraswat, clear with this? Tanish, Soham, Devansh, Archana? Clear. This is another most common thing that you get. D by dx of sine square pi by 3x plus pi by 6. How to do this thing? This is d by dx of sine It's easy only, just that pi and all will suddenly start looking scary. So this whole function ka square, agreed? So this whole thing inside is some function. So this is 2 into that some function, which is sine pi by 3x plus pi by 6 ka 2 minus 1, and then differentiate whatever is inside. So we have to differentiate now that sine ka function, pi by 3x plus pi by 6. So this is 2 sine pi by 3x plus pi by 6. Now this is sine of something, that is sine of a function again. So sine ka differential is cos pi by 3 plus pi by 6. Now differentiate whatever is inside, which is pi by 3x plus pi by 6. So this is again 2 sine A cos A. If you look at this whole thing, this is like 2 sine A cos A. This is sine 2 pi by 3x plus pi by 6. And that guy would be pi by 3x plus 0. So this is pi by 3 sine 2 pi by 3x plus pi by 3. Check. That sine 2 sine theta cos theta with sine 2 theta comes a lot. Matlab, have a look at this, the J part. Finish with K. K is root sine 3x. Any doubts on the J part? Please ask me. Any doubts on the J part? Please ask me. And others do keep your cams on. This is d by dx of sine 3x to the power of half. This is half into sine 3x half minus 1. Then differentiate sine 3x. So be careful. This is something to the power of. This is sine of something. This is 1 by 2. Right, sine 3x. That would be cos 3x. Then differentiate 3x. 3 cos 3x by 2 root sine 3x. Check. There. That is how you do this level 3 ka differentiation. Any doubts? This much you should be quite confident with. I know it kind of looks like max class today. Can't help it. Any doubts on this page? All clear? Going ahead? Devansh, Brijesh, Archita? Ridul, clear? Going ahead. Saraswat, clear? Saraswat, can I go ahead? Yeah. Next thing, differentiation of a vector. Now we start combining different chapters. It's not really difficult. This is one thing in physics. You learn chapter 1, you learn chapter 2, chapter 1 comes. You learn chapter 5, all 1, 2, 3, 4 will come. You learn chapter 14, all 1 to 13 will come. You can't do this in maths and chem. There is some connectivity, but physics is deadly. You do chapter 25, I can bring anything from 1 to 24. And in a way, that's an advantage and a disadvantage. Advantage is because no matter which chapter you're doing, all your concepts are being, always brushed up. The disadvantage is you messed up 4 and 5 chapters, you will have a difficulty in understanding. So once you can cover up the backlog, it becomes a big advantage. That's why if you see now, in the top 5,000 ranks, if you go and ask the people, what is your favorite subject? At least, 4,500 people will say physics is their favorite. Most people's favorite subject in the top is physics. So everyone does physics. No matter how tough paper you go, they'll still solve it. So the priority goes like this. The first subject is chemistry. Without chemistry, you won't even enter 5,000 ranks. Without physics, you won't even enter 2,000 ranks. What decides your rank below 1,000 is max. In top 500, right, the fight is between max only. In the top 1,000, like everyone must have done physics pretty well. Chemistry, everyone must have done pretty well. This max becomes a rank deciding factor. That is how the priority goes normally. So, yeah. And that is the advantage of for example, right now your senior school revision is going on. They study almost 10 hours per day. Yeah? Abhi kuch classes nahi hai na? All are done. Classes are done, exams are done, nothing. They're just preparing, sitting and studying. So this is how they go. They do 4 hours chemistry, 4 hours maths, and 2 hours physics. Kafi hai. Because physics is one subject, where I can give you 100 questions and I can revise almost 90% portion. You can't do that in maths and chem. There's a high level of connectivity in physics. So if you have a vector A bar, which is AX I cap, AY J cap, and AZ K cap. So if someone asks you to differentiate this vector dA bar by dt, you simply differentiate each component. Remember, you need not differentiate always with x. You can differentiate with t also, any variable, d by dt of y j cap. Like it's not really difficult. You just have to differentiate and put I cap, j cap, k cap, and done. That's it. So example, let's say if someone gives you like this, A bar is t square I cap plus t j cap plus t cube k cap. Now, if someone asks you to differentiate this vector dA bar by dt, this would be dt square by dt I cap dt by dt j cap dt cube by dt k cap. So t square ka differential is 2t I cap, dt by dt is 1 j cap, t cube ka differential is 3t square k cap. Getting how to differentiate this? So you take that each coefficient and differentiate and put I j cap and you're done. That's it. So differentiation of vector is not like anything big deal. You just differentiate each coefficient and finish it off. If I give you one more example, let's say someone gives you like this, E bar is 2x I cap plus x power 4 j cap. And if they ask you to find dE by dx, so you'll always know with what are you differentiating. So 2x ka differential is 2 I cap and x power 4 is 4x cube j cap. Have a look at this. Clear? Any doubts on this? So let me show you how they'll frame a question. Can I turn the page? Let's say we have v bar, which is a velocity vector. Which is given by t square I cap plus 1 by t j cap. T is time. And it is given a bar is acceleration vector is nothing but dv bar by dt. So matlab, if you differentiate v bar once, you'll get acceleration. Isn't it? Change in velocity by time. So the first question is find a bar as function of time t. This is how I will write. Remember in the beginning I told you what's the function. So indirectly I'm asking you just differentiate dv by dt. That's it, just differentiate this. The second question, find time when a bar is perpendicular to v bar. Let's get this. So first just differentiate once. That will give you a bar. See the first one. You want a bar, which is dv by dt. Means differentiate this. dt square by dt I cap. 1 by t can be written as t power minus 1 j cap. So t square ka differential is 2t I cap. Minus 1 ka differential is minus 1 by t power minus 1, that is t square j cap. So there, that's your acceleration. Please check. Anyone didn't get this, please ask me. Now, tell me one thing. Look at the second statement here. The vectors are perpendicular. What does this tell you? If two vectors are perpendicular, there is something there. Do you remember? The dot product is 0. There. So we combine differentiation with the acceleration, velocity, kinematics with dot product. 3 different chapters. So if two vectors are perpendicular, what is the dot product? The dot product is 0. That we did in vectors, scalar dot product. So remember that thing in physics, whenever you hear the word two vectors are perpendicular, indirectly it's telling you use the dot product is 0. That means if I do a bar dot v bar, it would be 0. So a bar is 2t into t square, 2t cube. Then minus 1 by t square into 1 by t, 1 by t cube is equal to 0. Then we have t power 6 is half. So the time is 1 by 2 to the power of 6th root. Are you getting what we did? So you're saying this vector and this vector are perpendicular. So do the dot product. How do you do the dot product? Multiply I components and multiply the j components. So you'll get 2t cube minus 1 by t cube is 0. So that will be t is equal to the sixth power of, the sixth root of 2, 1 by 2. Any doubts on this? Clear how we can combine vectors with differentiation? Clear with this? Any doubts on this page, please ask me. Okay, so that is the main thing about differentiation. The next part is actually applications, where we are going to do relation between velocity, acceleration, and all that stuff. And then we'll be doing maxima, minima, and all that applications, which are quite important. So I think that we will do once you guys are once we can recommence the classes after the next week, next week. So we'll wind up for today with this, right? So make sure to go through the entire notes. I'll try to send you a sheet on this. Now we will discuss the exam ka paper also. wo bhi hai. And the assignment is also there. Hope everyone has tried. So any doubts in that sheet and the paper we can discuss. So first, any doubts in today's class notes? Anyone has any query, any question in today's class notes, you can ask first.